Hey guys, it's your boy again, Jazzy, and welcome back to OpenSec Math. Today we have plenty to do, so let's just get right into it. In this video, we're talking about factorization. Before we understand factorization, however, we need to understand what are factors. Think of factors like ingredients in a recipe. For example, when you're making scrambled eggs, you would need eggs, obviously, some butter, a little bit of salt and black pepper, and if you're feeling fancy, a few cut up vegetables. Well, each of those ingredients are factors of scrambled eggs. Well, every number you can think of is also made up of factors. The factors of any number are all the smaller ingredient numbers that can divide evenly into that number, let's say x. When we say divide evenly, we mean that when you divide a number, there are no remainders left over. Let's look at an example with the number 8. First, think of the smallest number that divides evenly into the number 8. Well, the smallest number that can divide evenly into any number is always the number 1. 1 can divide evenly into 8 times. That means that 1 is a factor of the number 8. It also means that 8 is a factor of 8 because 8 can divide into 8 without any remainders one time. So both 1 and 8 are factors of 8. But those aren't the only factors of 8. Now, to find the other factors, continue trying larger and larger numbers up the number line to see if they are factors of 8. The next number in the line would be the number 2. 2 can divide into 8 without a remainder. Yep, 4 times, which means both 2 and 4 are factors of 8. Let's continue trying numbers as we go up the number line. The next number is 3. 3 can divide into 8 2 times, but it leaves a remainder of 2, which means that 3 is not a factor of the number 8. Let's continue moving up the number line. 4. 4 is the next number in the number line, but we already saw that 4 is a factor of 8 when we divided 8 by 2. After the number 4 is number 5. Is 5 a factor of 8? No, because 5 can be divided into 8 one time, but it leaves a remainder of 3. So 5 is not a factor of the number 8. At this point, you should recognize a principle. Any number larger than a number which is half of the number you are trying to find the factors of cannot be a factor of the number. So essentially, when going up the number line, to find the factors of a number, always stop at the number which is at the halfway point. Now that we understand how to find the factors of a number, now we can talk about factorization. Factorization is when we rewrite a number as a product of 2 or more of its factors. If we go back to our scrambled eggs examples, it would be like going to a restaurant and instead of ordering scrambled eggs, you ask the waitress for eggs mixed with salt, black pepper, butter, and some cut up vegetables. The waitress would watch you funny for sure, but in reality, you're asking for the exact same thing as scrambled eggs, just in a slightly different way. Well, it's the same with numbers. For example, if we were to factorize the number 8, we could factorize it in many ways. Instead of 8, we could rewrite the number 8 as 1 multiplied by 8 or as 2 multiplied by 4. This is how you find the factors of a number and then factorize that number. If you're just learning how to do this, it may take you some time to figure out the factors of a number. But as you do more and more of these questions, you learn the factors of numbers without having to break them down. And in this way, you'd be able to speed through these questions in no time. Now, so far, you just learned how to factorize a number. But let's look at something even cooler. Let's say we have the expression 2x plus 8. Each of the numbers in this expression can be factorized, yes. But let me tell you a secret. This entire expression can be factorized as a whole. Yes, just as how we found all the smaller numbers that when multiplied gives us the number 8, we can also find all the small numbers and terms that when multiplied will give us the entire expression, that is 2x plus 8. Here's how. Between 2 or more numbers or expressions, we can find something that is called the highest common factor, HCF. The highest common factor is exactly what the name says. It's the highest factor that is common between the 2 or more expressions that we are working with. So, in the expression 2x plus 8, we already found all the factors of 8. But let's see what are the factors of 2x. Don't be intimidated by the letter. Just take a deep breath and think about it. Use the first principle. What is the smallest number that could go into any number or term without leaving any remainders? That's right, the number 1. 1 can go into 2x times. What about the number 2? 2 can go into 2x, 1x times. And that's it. These are all the factors of the terms. 2x, 1, 2, 1x, and 2x. So going back to our expression 2x plus 8, between the factors of 8 and all the factors of the term 2x, which factors are common between these two sets of factors? The number 1, of course, and the number 2. Therefore, the highest common factor between 2x and 8 is the number 2. It's the highest one. Now that we know HCF, let's factorize this entire expression. Remember, factorizing is the rewriting of a number as the product of 2 or more of its factors. Well, for an expression with multiple numbers and terms, we factorize by first placing the HCF followed by an open bracket. Then inside the bracket, we put the factor that when multiplied by the number 2 would give us the original numbers in the expression. We do this by dividing each number in the expression by the number 2. 2x divided by 2 is equal to 1x. So we write 1x. Then positive 8 divided by 2 is equal to positive 4. So we write positive 4. Then we close the brackets. In the end, we have 2 open brackets, x plus 4, close brackets. As you can see, if you simplify this bracketed expression, we will get the original expression we started with, meaning when we factorized, all we did was rewrite it in a different way. Now let's look at factorizing powered terms. The first step is finding the HCF of the coefficient numbers. The HCF between 9 and 6 is 3. If you don't believe us, write down the factors of each on a paper and see for yourself. Secondly, factorize the powered terms. Get ready for this, because for the first time in your maths life, working with letters will be simpler than working with numbers. When there are powered terms that share the same base, yes, the same base, for example, x to the power of 5 and x to the power of 2, the HCF between the two powered terms is the term with the lower power between the two. That means the HCF between x to the power of 5 and x to the power of 2 is x to the power of 2. Easy, right? So we have the HCF of the coefficient terms, which was 3 as we found earlier, as well as the HCF of the unknown power terms, x to the power of 2. Put them together, 3 by x to the power of 2 gives you 3x to the power of 2. And that's your HCF of the entire expression. So, just as we did before, put 3x to the power of 2, followed by an open bracket. Then we put the figure that when multiplied by our HCF will give us the original terms in our expression. We do this by dividing the original term by the HCF just as we did before. So let's start with the first one. That would be 9x to the power of 5 divided by 3x to the power of 2, which is 3x to the power of 3. Then 6x to the power of 2 divided by 3x to the power of 2 is equal to 2x to the power of 0. Anything to the power of 0 is equal to 1. So that leaves us with 2 times 1, which is 2. And there we have it. That's it. That's how we factorize powered expressions. Our original expression, 9x to the power of 5 plus 6x to the power of 2, when factorized, equals 3x to the power of 2, that's our HCF, open brackets, 3x to the power of 3 plus 2, close brackets. But okay, we have one more tool to teach, which would be important for the lesson in our next video. So let's look at how to factorize by grouping. We use factorization by grouping when there aren't any clear common factors shared by all the terms and numbers in the expression. So instead of finding the HCF of the entire expression as we did before, we group the first two terms together and then the last two terms together and then factorize them separately. Now that we have them grouped, let's factorize them just as we learned to do before. The HCF between the coefficients 1 and 8 is equal to 1. And the HCF between the power terms y to the power of 2 and y, remember y is y to the power of 1, right, is the one with the lower power. Which one? Y, or y to the power 1. Factorized, y to the power of 2 plus 8y becomes y, open brackets, y plus 8. And if you expand them, you'll get back the same thing as before, the original. Now let's look at the second grouping. The HCF of the terms 2y and 16 is 2. Again, work it out on your own if you don't believe us. Get as much practice as you need until you don't need to anymore. Factorized, 2y plus 16 becomes 2, open brackets, y plus 8. And remember, you could always expand it to ensure that you get back your original answer. That's how you'll know you're correct. Now, what have we noticed here after we factorized? Well, if you look closely, there's a common expression of y plus 8 in both groups. Because the two groups share a common factor, this can be rearranged by placing the outer terms in each group in a bracket of their own and multiplying it by the common factor between the two groups. Now, if we use what we knew about multiplying brackets from before, we will see that when we multiply these two bracketed expressions together, it would give us the exact expression we began with. And that's how we factorize by grouping. And that's it for today. If you missed anything, as we always say, just rewind the video and watch it as many times as you like. And as always, remember, don't panic. It's just maths. This episode of OpenSec has been sponsored by BP and produced by the 2 Cents Movement and these beautiful people. Don't forget to subscribe, like, and turn on post notifications for more videos. Until next time, vámonos!